Hi, today we're going to continue with exponents and learn a new thing called logarithms that helps with dealing with exponents. Number one, before we start, we're going to do some background questions. Number one says, what exponent do you need on a base number of 5 to make it equal to 25? Well, that one's rather easy. 5, you would have to have a 2 power to make it equal to 25. So the answer would be 2. Number 2, what exponent do you need on a base number of 2 to make it equal to 32? We could guess. If you don't know this one, again, they will get more familiar to you as you use them. You could try 2 to the 4 power. Nope. Try 2 to the 5 power. So it would be 2 to the 5 power makes 32. So that would mean the exponent would be 5. Number 3, what exponent do you need on a base number of 4 to make it equal to 64? So 4 to what power is 64? Again, we could just try to guess. Well, I know 4 squared is 16, so let's try 4 to the 3rd. And that's 64, so it would be 3 power. What exponent do you need on a base number of 9 to make it equal to 3? So this one is a lot harder. 9 to what power makes a 3? Well, it has to be under a number 1 because 9 to a 1 power would be 9. And I don't know if you realize, but the square root of 9 is 3. So the square root of 9 is 3. And in order to do square roots, you learn that you could have a fraction where 2 is the root number, so you put it on the bottom, and 1 is the power, and that would be the square root of 9. What exponent do you need on a base number of 6 to make it equal to a 1? So 6 to what power would make it equal to 1? And the only power that makes anything equal to 1 is a 0 power. So 6 to the 0 would equal 1. Oh, apologize, this is 1/2. Now, some of these were easy and some of these were a little hard, like 4 and 5. So we have actually a math thing called logarithms that actually helps us deal with powers in specifically. So I'm going to go back to question number 1. The question was, the base number is 5, you want to make it equal to 25, and the answer is 2. So we would write that like this. The log base 5 to make that be a 25, the exponent is 2. So what I wrote in red is exactly what the underlined means. So the next part, what exponent do you need on a base number of 2 to make it equal to 32? So you would write the log that makes a base 2 make a 32 value is equal to 5. The next question, what exponent do you need on a base number of 4 to make it equal to 64? Again, base number is 4, you want a 64 value. The exponent log, that's what that means, to make a base number 4 become a 64, the exponent is 3. So on a problem like 4, this is why this would be more useful. It was a little bit harder to realize it was a 9 or a 1/2. So the base number 9 to make it equal to 3, we would write log base 9 to make it equal to a 3 is what? And if you didn't know, well, we could actually find that value by using our calculator. We can do logs on our calculator. Now, I'm going to get into this in a minute, but this log is for a base 10 only. So since our problem in 4 has a base 9, we have to use a different key on the 84. On the Inspire calculator, you can use that log key because you're able to change the base number. On the 84 calculator, you want to go to Alpha Window, and then there's number 5 is called log base. And, whoops, I hit the wrong one. Sorry, I keep hitting the wrong keys. So if we go down a log base, number 5, you can put a 9 there. That's your base. The value you want out is a 3, and it'll tell you the power is 0.5, which is a half. So this is a great way to deal with powers, especially when it's not as easy to understand what the power is. And then same thing with number 5. What exponent do you need on a base number of 6 to make it equal to 1? So we would write the log that makes a base 6 become a value of 1 is equal to, now again, we figured out it was 0, but if you want to see that, alpha window, log base number 5, we want a 6 base to be a 1 value. And the exponent is 0. So you have to realize that the number after the equal sign is the power. Log means the power, the exponent. So the exponent is 0. All right, so today's lesson, we're just going to continue just with understanding this log and how to write it from different forms. So a logarithm is the power to which the base must be raised in order to get a certain value. And the box shows you the 2 different forms. On the left, it's the exponential form, where you have a base number raised to an exponent number and then equals a certain value. And on the right, you have the log form of that same expression or equation. So the log base b of to get a certain number is equal to the exponent. Okay, so what we have to just learn for today is how to or understand what logs are. So we're going to first, for example 1, rewrite each of those in log form, and then we're going to example 2, rewrite all the log forms back in exponential form. All right, so problem example 1a, 2 to the 3rd power equals 8. So if I write that in log form, that would mean that the log, again, exponent is another word for log, the log slash exponent that makes a base number of 2 become a value of 8, the exponent is 3. I'm number B. So we have, now if you see that's a 4, that's the power, you know that if you have log over here, you know that the power has to be on the other side, because that means the exponent is 4, what I just wrote. The base number goes lower, so the base number is 3, and you want to get a value of 81. All right, so 3 to the 4th equals 81, and log base 3, 81 equals 4, mean both the same thing. So off to the side, I have like a way to help you remember what to do. You can do the circle method or drop and switch. And this is what I mean by drop and switch. You drop the 9 down and you switch the other 2 numbers. So 3.5 gets switched. And the circle method would be to say, start with 9 and circle around, and that's how you get your numbers where they go. That's just a way to do it if you want some kind of cheat way to help you remember. I just like to try to do it with just the understanding of what a log is. All right, so example 2, we now want to rewrite the log equations into exponential equations. All right, so we have the base is right here. The base number is the lower number. The base number is 5. This is the value you're trying to make it equal. And the exponent is always on the other side of the equation for logs. The exponent's 3. And then you can actually test these out. 5 to the 3rd power does in fact equal 125. So B, we have the base number is 4. Then the power is on the other side. The power is 3. And we want the 4 to the 3rd to equal this value right here, 64. All right, and lastly, if I want to use my just little mnemonics to help us out, if you do drop and switch, we're going to drop the log and then switch these two around. And that would be another way to help you remember how to do this. 27 is the base, 1/3 is the power, 27 to a 1/3 power equals 3. And again, if you remember, this means the root, and that means the power. So the third root of 27 is 3, and 3 to the 1 power is 3. All right, so changing forms is really something you need to learn how to do. And after that, we're just going to do a little bit of simple solving and evaluating. So on problem example 3A, it says evaluate. Now evaluate means to find the value of. So I want to know the log base 6 of 216 equals what? Now there's two ways to think about this. Basically this question is asking what exponent do you put on a base number 6 to make it have a 216 value? So basically the question is saying 6 to what power is 216? So for something like this, you could try to guess what it is. It may not be a nice number, so we could try 6 to the second power is 36. So it's not that. 6 to the third power is 216. So that means that this is equal to 3. That's the power that's going to make that true. Now on these calculators though, you can just simply type it in. If I go to Alpha window or your log base key on the Inspires and you actually type it in, see, you will get 3. I just want you to make sure you realize what it means and not just rely on typing it in. So problem B says the log base 25 to get 125 is equal to what? So again, that means 25 to what power equals 125. So we could take a guess. All right, well, 25 squared is already too high, so it must be some fraction. I can sit here and try to guess what the fraction is, or I can make this equal to an x power, and I can solve using what I learned last class by changing bases. 25 and 125 share a common 5 base. 25 is 5 squared, and then we still have the x power, and 125 is 5 cubed. And then I can set the powers equal to each other and solve. So the answer is 3/2 or 1.5. Again, I know that we can do it on our calculator, but I still want you guys to understand what is happening. So I'm going to do it now on the calculator. If I do alpha base or alpha window log base and I put my 25 base and I put my 125 value, you will get your 1.5 power. All right, so that is what that means. So you can use your calculator, just understand what though the calculator is doing. All right, and lastly, C. When there's no base number, and this is important, and I have it over here on the right in my box, when there's no base number, it means that the base number has a default of 10. There's always a default. And I'll just go back to some things you already know. For instance, when you have an X, it means that there is a 1 in front of it, right? We know that that's a default. When we have an X, we also know that we have a 1 power. That's a default. When you have a square root of X, we know that there's a number here default too. So there's always a default. So when there's no base number, it really is a base number 10. I know we can put these in our calculator, but just again to understand what this is saying what exponent do you raise a number 10, what exponent to make a 100 value? And this one is actually easy. It's 2, right? 10 squared is 100. So the answer is 2. On the on this calculator, the 84, you can just hit the regular log key and put 100. It knows the base is 10. Or you can use the alpha base, and you guys with the Inspires will also have this format. You can leave that blank, or you can put a 10 for the base. So if I leave it blank, on the Inspires, if I leave it blank, you're fine. I'm going to just check on the 84 what happens. All right, so on the 84, it won't let you leave it blank, but on the Inspires, you should be able to leave it blank, and it will default to a regular log. If you're going to use this on the 84s, you do have to put the 10 there. But as I already said, on the 84s, you can just hit that other log key, and it'll work. All right, one last one. For A and B are simple solving. So the A, B, and C in example 3, the x that we're looking for is at the end after the equation, so we could use our calculator. For problems 4, that's an equation, so we can't just type that in. So when you have the x in these two spots, you're going to have to do it a different way. For example, for A and B, when the x is in the base or the value, you're going to have to change forms. Okay, so 9 is the base, x is the outcome, 2 is the power. Now once I do that, I can now easily see that 9 squared is 81, and that's my answer. B, again, anytime the x is one of these two, I'm going to change forms. So x is the base, 5 is the power, and I want an outcome of 243. All right, so at this point, I have to go back, and you already taught this. How do I get the 5 power off so I can see what the x number is? And if you recall, we did this a few days ago. In order to get rid of a 5 power, you have to do the reciprocal power. So you're going to raise both sides. This is really over 1, so we're going to raise both sides to the 1/5 power. These two powers will cross each other off because reciprocals make a power of 1. And then all I have to do is put 243 to the 1/5 power. And we get 3. As always, you can do any equations on your calculator. I didn't have you write this down, but I'll just show you. Just like I've been saying all year, if you want to, you can put the left side of the equation in graph 1. So if I go back to example 4a, I can put log base 9x. And then put 2 on the other side of the problem. And then I can check my graph and my table. Now we already know the answer is 81 for this problem, so the answer is pretty far out. You can also go to the table and try to do it that way. Again, you'll be scrolling a while, so I'm just going to help us out. I'm going to go to my table set and start my table at 80. And then once you scroll up, you'll finally see that there's a match on these two. Okay, you can try a few problems in the practice sections and then check your answers if you'd like.